Hi everybody, welcome to the section 2.3 video where we are going to be learning about linear equations and the integrating factor. So the learning objectives for this section are going to be define what linear equations are of first order and what their standard form is, analyze the method to solving these linear differential equations, and then, of course, solve some initial value problems that are of linear equation form. So let's go ahead and introduce what a linear equation is. So this is our next step in solving first order differential equations analytically, meaning some type of solution method that's not graphical or numerical. So something by hand, essentially. And the next type of equation we're going to learn is linear equations. Okay, so this is something new to solving a differential equation. Something like separable equations is something that was probably covered in Calculus 2 to some extent, and it was a bit of a review. But now we're going to learn something brand new for differential equations that you probably haven't seen before. Okay, so linear differential equations are considered a friendly family of differential equations. This is due to whether the linear equation is of the first order or of higher order. There is always a good possibility that the solution to the equation can be studied. Okay, so let's look at the definition of a linear equation. So a first order differential equation of the form dy over dx plus p of x times y equals q of x. This is said to be a linear equation in the variable of y. So let's break apart what these terms are in our differential equation. So P of x is some function of x. It's some function of x, could be x squared, uh, x could be a constant, some type of function of x, and it's going to be multiplying just y. So this is just a variable y. So it needs to be just a variable y for it to be a linear equation. Okay? And q of x is just another function of x. So this is what a linear equation looks, and this is also what the standard form of a linear equation is. Okay, so we have another linear equation. We're going to learn another method to solve. So our goal with these types of linear equations is just to solve a differential equation that looks like this. Okay, so a couple key features of this. A linear differential equation connects back to linear and linearity. There are two functions of x, p of x and q of x. Y appears in the first power, okay? That's very important to it being a linear equation. It has to be in the first power, and it's multiplied by p of x, which is just some function of x. Could be like x, could be a constant like 2, x squared, uh, x, some function of x, okay? And also, the derivative dy over dx has to be what's called naked, meaning it's nothing's multiplying it, it's by itself. Okay, so here's a straight method to solving a linear equation. You kind of want to go in these steps. Okay, so sometimes there's a step 0 And that step zero is putting the linear equation into standard form. What does that mean? It just means getting our derivative dy over dx naked. Getting it naked, isolating, whichever clicks for you, but that's always step zero. We call it step zero because sometimes the question for the differential equation is given to us with dy over dx already naked, but sometimes it's not. So we say step zero. That's the first thing we got to do for the problem, just in case. Step one, calculate the integrating factor. So this is something we're going to learn that's quite new, the integrating factor. That's something we got to calculate. And it's, we like denote it with the Greek letter mu. So we say like mu equals e raised to the integral of that x function p of x d of x. So that would be our integrating factor. We'd calculate it and we would get some mu. And what we would do with that mu after in step two is multiply to both sides by that mu, which is the integrating factor. Okay, so we get down to step three, and what do we want to do with differential equations? We just want to integrate both sides and solve. Okay, so that is the definition of a linear equation, the key components of it, and the game plan to solving them. Okay, so we're going to go ahead and solve a couple, but that will be in the next videos. So that's it for this one. Take care, and I'll see you guys in the next video. Okay.